All right. So hopefully you can hear me okay. But I'm going to do this problem here. All right. So I'm doing it at the board here. We want to write the formula for this function in terms of n. Okay. So when we see this like this, if the function is f of m, then we can think of it as n equals, and then get everything over on the other side. That's all you gotta do. So I'm gonna rewrite it. And I'm gonna put my n on the left and everything else on the right. So the n term is 6n. Okay, so that's gonna go on the, did I say right? On the left. Everything else is gonna go on the right. All right, so the 7m, that'd be negative. The 2 is negative. The 5 is already there, and that's negative. Okay, now let's combine like terms. All right. Negative 7m, negative 7. Now, we got to get rid of that negative 6. How are we going to do that? Divide. I always like to divide every term instead of both sides because it's a little bit clearer what's happening. So the negative 6 is canceled. The 2 negatives right here cancel. And so that's just 7/6. And then the 2 negatives there cancel as well, which makes it plus 7/6. So the answer is 7/6 m. Now I want to make sure that m is either in the numerator or to the side of the fraction. And plus 7/6. Seems wrong, but it's right. Okay. Let's turn that down a little bit. All right. So what in general, what did we do? We got.
Okay. I got it. I rescheduled it.
Got it. No problem. Mm-hmm. All right, let's move on to the next one. Whoa, word problems. All right, let's read it. Princess Tower in Dubai is considered the world's tallest residential building, towering to 101 floors. T of n, but we're gonna make a taller one, right? T of n models the number of tenants living on floor n of the tower. So in this one, just like word problems from systems, when we wanted to know what the variables are, here we want to know what the variables are, all right? So we have T of n. I thought I was here. T of n is what? T of n is number of tenants living on the floor. That's the number of tenants. It's talking about an amount of people. And what is n? N, I can tell you what n is. Floor n. N is the number. Oh, I don't know why am I eat number of floor or floors. It's the floor number. So not the number of floors, it's the floor number. All right. So what does the statement T of 60? So what is T of 60? That is the number of tenants on floor 60. So that's total tenants can't make, it's not, let me make a, oh, let me try to use. I know what to do. I will use my annotate. This is the total tenants on floor 60. And so what is T of 10 and T of 30? Those are the total tenants on floor 10 and floor 30. And what is it saying? When we add the tenants from floor 10 and 30 together, the number, it's still less than the number on floor 60. I wonder what's happening on floor 60 that everyone wants to live there. Okay. Are we talking about height? No. Are we, the number of floors with 60 tenants? No. It's the tenants on floor 60. There are more tenants on floor 60. Yes, this is looking good than on these two combined. I couldn't have said it better myself. All right, moving on. Okay. All right. Take some notes because we're about to talk about one of the most important topics, domain. Domain and range. We won't talk about range just yet, except to say that domain is the x values. Range is the y values. That's it. But it's all the possible x values and all the possible y values, which in a general function can be all real numbers if everything works. But sometimes, okay, hold on, I gotta pause it. Mr. Johnson needs to let me. Oh, right. So as I was saying, in life, sometimes the domain starts at 0 or some other number. And so we'll see restrictions on the domain. Also, sometimes you can't use some numbers, like we can't divide by 0 or we can't square root a negative, right? All right, so what's the domain of G here? Well, G is a discrete function. You remember that? Discrete. And also, let's see, what are the x values? So, okay, so the domain. The x values are, let's see, 0. What's the x value of this one? 2. Nothing at 3. This is 4. And it's the x value 4. 5. And 7. And you like to use the curly brackets for the domain. There they are. Now you see the inequalities there. Why, Mr. Field? Why do they have inequalities? Well, that's because sometimes it's not discrete, it's continuous. And so, when it's continuous, we just look at the endpoints. Or sometimes there's no endpoints, in which case it's an inequality. A different kind. So the endpoints are -5 and 5. So it's like this. But hey, should it be or equal to or not? Well, it's a closed circle. So it's going to be or equal to. All right. Let's see if we got the answer. Oh, yeah. All right. Let's do one more. No. All right, moving right along. Whoa. Now, here's what I was talking about. Sometimes you get numbers, you get things, and you can't include them in the domain. Here, we have what I like to call a denominator. Now, 0 cannot be in the denominator. 0 cannot be in denominator. So you might say, is 0 in the domain? Well, if you substitute 0 in to the function, currently there's a 0 in the denominator, but when I simplify, it will become -3/2, which is just fine. So that is in the domain. But now let's substitute -2. -2 minus 3 over -2 plus 2. -2 plus 2 is 0. Bad news bears. 0 is in the denominator. And that's just not going to work. Sorry, -2. You didn't make it. But now I see that anything else I were to substitute would work, including 3. I don't have to do the math to know that 3 is in the domain. But you can, if you like. All right, that was so fun. Now we better do this one too. Does this one have a denominator? No. Does it have a square root sign? No. Is there any number I can't substitute? No. All right, they're all gonna work. Aha. This one has a square root sign. And what have I been saying this whole time? You can't square root a negative. So what we do is we take whatever is underneath the square root sign, and what is negative? It's something less than 0, right? So this has to be greater than 0, or it would be negative. Greater than 0. Can it be equal to 0? Good question, right? What's the square root of 0? It's 0. That's easy. So it can be equal to 0 too. It just has to be greater than or equal to. All right. So when you solve this, we just divide both sides. All right. So anything greater than or equal to 0 is in the domain. Anything less than 0 is not in the domain. But had a different expression been underneath, then it would have been different. Like if I had x plus 3 under the square root sign, now when I make that greater than or equal to 0, I'm subtracting 3 from both sides, and I end up with x is greater than or equal to -3. So all the values have to be greater than or equal to -3, not 0. So make sure you have that in your notes too, because I guarantee you some people are going to only think about 0. Oh my goodness, this is not good. Do you know what? I know what I did wrong. I know I did wrong. What did I do wrong? Does anybody know? You know? I did not flip my inequality sign. But I'm flipping it now because, that's the right answer. So now when you flip, because why did we flip? Because I divided by a negative and I'm supposed to flip my inequality sign. So now what does that mean? It's all backwards. So you don't have to forget everything I just said. You just have to remember to flip your inequality sign when you divide by a negative. See? Moving right along. What is the domain? So now that we know what numbers cannot be in the domain, because we can't divide by 0, so we set that equal to 0, and it'd be -2. So that means that the domain is everything but -2. And the way we say that in math, everything, we say all real numbers. because the system of numbers that we use in the world are called real numbers. Now, there are imaginary numbers, but we won't talk about those until Algebra 2. Although, maybe before the winter map, I'll show you a little bit about them, in case you get those questions. This one, there it is, all real values. There, got it right. Last one. Oh, wow. All right. It's a word problem, but guess what? It's not that difficult of one. Okay. So we have to decide if we're going to use integers or real numbers. So does that means are decimals allowed or are they not allowed? So when can we not use decimals? Decimals, no. All right. When are decimals good? Time, like 5.6 seconds. Or weight, 8.2 pounds, or height. There's lots of times when decimals are okay, but when are decimals not okay? People. You can't have 2.3 people. Hold on, I gotta pause my video.
One question.
Yeah.
Peer tutoring in the morning.
All right. So let's see. So people can't have 2.3 people. Also, not as controversial, but you can't have cars, books. You know what? There's a lot of books. There's a lot of things that can't be decimals, right? Well, maybe you can have read 2.7 books. Not done with one. But anyway, let's see. So which is the appropriate domain for T? So what is the X value? T of A. So what does A represent? I haven't even read it. We're talking about altitude of boiling an egg. We're talking about seconds. We're talking about meters. Well, there's no reason why either of those can't be all real numbers. Now, what is the domain? Now I gotta go forth and read it. All right. So let's see. Altitude takes on 198. The highest place, it takes 209. Okay. Okay, so the domain, tricky. A is meters. So meters. So it starts at -418 and it goes up to 8,848. So let's find that one. It's right there. So see how I had to know what my variables were, and then it was easy. Yeah, and I'm right, so that's good. All right, guys, I'll see you in class. Bye.